Ever wondered how a single, tiny molecule can completely flip your reality on its head? Well, today we are going on a journey, a deep dive into the brain to answer that very question. We're going to travel from the chemical level to the cell, all the way up to entire brain networks to really get a handle on the neural basis of the psychedelic experience. So, let's get into it. And really, it all boils down to this one question. How can something so small, it's literally microscopic, create an experience that can feel, well, infinite? To even begin to answer that, we've got to zoom way, way in and start at the very bottom, at the chemical level. All right, so let's get right down to the molecules themselves. You see, the secret to their incredible power isn't magic, it's chemistry. It all comes down to their shape, their structure, which acts like a very specific key designed for some very specific locks inside our brains. Okay, check this out. What you're looking at is basically a chemical family tree for psychedelics. And that little bit that's highlighted, that's the pharmacophore. Think of it as the essential skeleton that pretty much all of them are built on. It's a very particular shape, an aromatic group connected to a nitrogen atom. This is the master key. Now, from that one master key, the family kind of splits into two main branches. On one side, you have the tryptamines, like psilocin, which you find in magic mushrooms. They've got that double ring indole structure. And on the other side, you've got the phenethylamines, like mescaline from the peyote cactus, with a simpler phenyl ring. Tiny little tweaks to the skeleton, but they lead to huge differences in the experience. But that brings up a question, right? Why is a tiny, tiny speck of LSD so much more powerful than, say, mescaline? Well, a huge part of the answer is rigidity. Molecules like LSD are built in a way that they can't really flop around. This rigid structure helps them fit perfectly, like a really snug fit into their target receptor, which just dramatically cranks up their potency. Okay, so we've got these chemical keys. Naturally, the next question is, what are the locks in the brain they're designed to open? The answer turns out to be a very, very specific protein that sits on the surface of our neurons. And this is the lock, the big one, the serotonin 2A receptor, or 5-HT2A for short. And this brilliant illustration shows exactly what happens when that key slides into the lock. It doesn't just sit there. The moment it binds, it triggers this massive chain reaction, a whole cascade of signals that completely changes what's happening inside that neuron. So let's just break that down, because it looks complicated, but it's really a simple chain reaction. 1, the drug binds to the receptor. 2, this wakes up something inside the cell called GQ protein. 3, that protein unleashes a flood of calcium. And 4, that calcium flood completely changes the neuron's electrical activity. It's like flipping a single switch that sets off a whole warehouse of dominoes. And look, this isn't just some wild theory. The science here is solid. I mean, the evidence is overwhelming. Scientists have done studies where if you block this one specific receptor, the 5-HT2A, with another drug, the psychedelic experience in people just almost completely vanishes. This is the lock. But here's where it gets really wild. The story doesn't just stop with a temporary change in a neuron's firing rate. What's absolutely revolutionary is what seems to happen next. Activating this whole pathway appears to trigger real, long-term, physical changes to the neurons themselves. I mean, just look at this. Research shows something absolutely incredible can happen after just one dose of psilocybin. The number and size of these things called dendritic spines. They're the tiny little connection points between neurons. They can increase dramatically, especially in the cortex. This isn't just a chemical change anymore. The brain is physically rewiring itself. And if you think that's wild, get this. This isn't some fleeting change that's gone by morning. Studies have shown that this new, denser network of connections can actually stick around, staying elevated for up to a whole month after just that one dose. This could very well be the biological reason for the long-lasting therapeutic effects we're seeing in clinical trials. So it's not just about building new roads, it's also about changing the traffic patterns on the old ones. But, and this is super important, it's not like one big on or off switch for the whole brain. As you can see here, the effects are totally different depending on where you look. In some brain regions, activity gets turned down, while in others, the neurons can just about stop firing completely. All right, so we've gone from the molecule to the cell. Now for the final leap. How do all these tiny little changes in millions of individual cells add up to something as profound and all-encompassing as a psychedelic trip? Well, to answer that, we have to zoom out one last time. to the level of entire brain networks and some really incredible theories about consciousness itself. So, we've got the chemistry, we've got the changes in the neurons, but how in the world does that become, a trip? That's the million-dollar question, and right now, there are a few fascinating and sometimes completely contradictory models trying to explain it. So, one of the first big ideas is something called the CSTC model. The simple way to think about it is that our brain has a gatekeeper for all the sensory information coming in from the world. It's called the thalamus. This model basically says that psychedelics throw open the gates, just flooding the higher parts of the brain with raw data that it normally filters out. A more recent and really popular idea is the rebus model. Think of it like this. Most of the time, your brain is running on autopilot, using past experiences and beliefs, that's top-down processing, to predict what's going on. The rebus model says psychedelics basically turn down the volume on those predictions, allowing more raw bottom-up sensory data to actually get through. Your brain becomes less about what it thinks is there and more about what's actually there. But, and this is what makes science so cool, there's a totally different theory, the strong prior model, that says the exact opposite. It points to data showing that psychedelics can actually reduce the amount of sensory info coming in. This model suggests that with less data from the outside world, the brain overcompensates and relies way more heavily on its own internal models. Basically, it starts hallucinating to fill in the blanks. So let's put these two heavyweights side by side. You've got rebus saying the brain becomes more open and sensitive to the outside world, while the strong prior model says it turns inward and listens more to itself. Two totally opposite explanations for the same wild experience. So who's right? Honestly, the truth is probably some complex dance between both, and figuring that out is one of the most exciting challenges in neuroscience today. And all of this, it brings us right to the cutting edge. I mean, we've learned a ton, but the reason this field is just exploding right now is because of all the huge fundamental questions we still have. For instance, do you actually need to have that crazy mystical experience to get the antidepressant benefits? We still don't know for sure. And which specific dominoes in that signaling cascade lead to the long-term growth of new connections? What about all the other receptors these drugs tickle? And how do different types of neurons, even neighbors in the same circuit, contribute to the whole shebang? These are the questions that are driving the next wave of discovery. And really, that leaves us with one last big idea. These molecules are more than just drugs. They're extraordinary tools for basically reverse engineering our own consciousness. By understanding how they reshape our brain from the molecule all the way up, we're not just learning about psychedelics, we are getting this incredible, unprecedented look under the hood at how our own reality is built, and ultimately, maybe even the nature of the mind itself.